Good afternoon, students. Welcome back once again to the mathematics class. In the last lecture, you have completed, that is exercise 13.4, based on probability distribution, right? So now we are moving to the last concept of the chapter, probability, right? That is nothing but Bernoulli's trial. Bernoulli trials and binomial distribution. So before going to start binomial distribution, we have to understand first what is Bernoulli's trial, right? So in many experiments, we can see, for example, a tossed coin always show two possibilities. A coin is there. For example, we have coin, 1 rupee coin, let's see, which has two possible outcomes. One is head and another is tail, right? And in case a manufactured item can be, for example, an item is there, a bulb is there, either it is defective or non-defective, right? Two possibilities, and the response to the question might be, if I ask a question, there will be two answers. First one is, do you know? Yes, or one more is no. Two possible outcomes, right? For example, in such cases, it is customary to call one of the outcomes as success. Out of these two, any one we can say success and other is failure. Either anyone, either it may be edge, when tossing a coin, either it may be head or tail. We can take anyone. If I take head as success, then tail will be failure. If I take defective as success, non-defective as failure. If I take S as failure, no as success, like this, right? Only two possible outcomes we can get, either yes or no, defective or non-defective, or tossing a coin head or tail. If the occurrence of head is considered as success, then occurrence of tail is what? Failure, here in the first example. If I take head as success, then T as failure. So each time we toss a coin or roll a die, we perform any other experiment, we call it a trial, right? If you take any example, first, second, third, you can take coin or a die, and it can be anything, right? So we call it as a trial. उसे क्या बोलते हैं हम? We call it as a trial. Got it? If a coin is tossed, say 4 times, if a coin is tossed 4 times, right? The number of trials is what? The number of trials is 4, each having exactly two outcomes. A coin is tossed 4 times means each time, in each toss, exactly two outcomes, namely success or failure. Already, as I said, success or failure, either it is head or tail. If I consider head as a success, then T automatically it will be failure. So the outcome of any trial is independent of the outcome. Independent means here, suppose if a bag contains, let's see, suppose if a bag contains 4 red balls and 6 black balls, if I say find the probability of getting a red ball, find the probability of getting a red ball means with replacement. Find the probability of red ball, drawing a red ball, red ball with replacement I am saying. With replacement means total 4 red balls. 4 red balls are there out of 10. We'll get 4 by 10 will be the probability for drawing a red ball. With replacement means in the second drawing it 3 times. If I take drawing a 4 times, let's take. Find the probability of 4 times drawing a red ball. Probability of 4 times drawn a red ball with replacement we are saying, right? So with replacement means what will be the, in the first draw picking a ball it will be 4 by 10. Let's see here, with replacement it is without replacement, right? With replacement means we'll get 4 by 10, 4 by 10, 4 by 10, 4 by 10, right? They are not depending on each other. They are independent. But here, without replacement means in the first drawn we get 4 out of 10, in the second 3 by 9, it is 2 by 8, it is 1 by 7, right? So, these are depending on one another. So here they are dependent, this one is independent, right? It is independent. So independent of outcome of any trial, in such case or in such trials, the probability of success or failure remains constant here. Right? So here if I take 4 outcome means if we are getting 4 successes, then 4 successes are remain constant only. There is no change in that constant, right? So there is no change in that trial we can say. Got it? So such independent trials which we have only 2 outcomes usually referred as success or failure, and they are called what? Bernoulli's trial. Right? So let's see definition more precisely. Let's see the definition. What is the definition for Bernoulli's trial? So here, trial of a random variable, trial of a random experiment are called, trial of a random experiment are called Bernoulli's trials. Bernoulli's trials. If they satisfy the following conditions. Following conditions. So let's see. First condition it should be finite number of trials. Should be finite number of trials. Or simply we can say it should be finite. Second one, the trial should be independent. As I said in the earlier example, a finite, and second one it should be independent. Third one is each trial has each trial has exactly two outcomes. Dual nature it should be. Each trial has exactly two outcomes, either it is failure or success, right? So then only we can say it is a trial, Bernoulli's trial. So finally fourth one, the probability of success remains the same in each trial, remains the same in each trial. It means again it is independent only. In each trial means independent, already we have seen here. So it is independent means all the trials are equal. There is no change. They are constant throughout the end of the experiment. So here in the dependent variable we can see the changes. It becomes 4 by 10, 3 by 10, 2 by 10, 1 by 7, right? So but here in the independent event we are getting 4 by 10, 4 by 10 with replacement we are saying. See here it is replacement. It is without replacement. No replacement here, right, in this section, right? So got it? What is Bernoulli style? So for example, if I take for Bernoulli style, for example, throwing a die 50 times. For example, let's see, throwing a die 50 times is a case of 50 Bernoulli trials, right? 50 Bernoulli trial. If we are throwing a die 50 times means what are the number of Bernoulli trials? 50 will be Bernoulli trials in which each trial result is success, say an even number. For success we are taking what? Even number obviously, or failure. Failure will be if they are even number means other side what we get? Odd numbers. So and the probability of success be P. P is denoted as success in same for all 50 throws. Obviously, the successive throw of the die are independent experiment means with replacement we are doing. If the die is fair and have a 6 number 1 to 6 written on the faces, then what it will be? P equals to what we get here? 1 by 2. The successive throw of the die are independent experiment. If the die is fair and have 6 numbers 1 to 6 written on 6 faces, then P will be 1 by 2 and Q will be 1 minus P. It will be 1 by 2. What will get? Probability of failure. Q stands for what? Failure, and P stands for success, right? So now we are moving towards binomial trial. So already we have binomial trial. So let's see what is binomial trial. Already you know what is X. X is a random variable, right? X is a random variable. We are getting success R at a time. We are getting success R at a time. Probably. We are getting success R at a time. Then the first case, if we take the Bernoulli's trial, what it says, first one is it should be finite, means if we take n number, n means n finite numbers, then there are two successes with respect to each trial has exactly two outcomes, means one is R success, another is n minus R failure. So it is success, this one is failure, right? So now we can write it as probability of x equals to R success, we are getting random variable x which is equals to R times we are getting success, means how can we write n C R, n combination R success, out of n we are getting R successes, means we are getting NCR, whereas P stands for what? P stands for success. Finite means 1, 2, 3 up to R times success, means we are taking P to the power of R. If we are taking P as a success, then for failure it will be Q raised to N minus R will be our probability distribution, binomial distribution formula, right? So we can remember this. What will be the formula for binomial distribution? Basically it satisfies Bernoulli's trial condition, that is it should be finite. In the second, it should be independent, and third one, each trial has exactly two outcomes, failure or success. And the fourth one is probability of success remains the same in each trial. Got it? So now the binomial distribution is nothing but probability distribution for x which is equals to R success, we are getting R is nothing but success, whereas n minus R is a failure. So we are considering NCR. Out of n we are getting R successes, and P stands for what? Already we know P for success and Q for failure. So R times success means P to the power of R, already we have here. So n minus R failure, so it means Q to the power of n minus R we are considering, so which is nothing but our binomial distribution formula. So with the help of this formula we can solve exercise 13.5, right? So 13.5 is totally based on Bernoulli's trial and binomial distribution. Got it? So if you understand the concept, then it is very easy to solve exercise 13.5 questions. So with this, we will conclude our today's lecture. In the next lecture, we will discuss or solve the questions based on exercise 13.5. So till then, take care, stay at home, stay safe. Thank you.